Hi, my name is Francesca Weikert. I am currently a first-year student at the Western Washington University in Bellingham, Washington. I'm studying environmental studies and anthropology, and right now I have the opportunity to partake in a one-month internship with Professor Hersh Chadha in Dubai. For this assignment, I looked at different resources and videos, articles, books, a lot of them by James Baylog Extreme Ice Survey, talking about the effects that glacier melting is having on our environment and on us as human beings. I'm really intrigued by this topic because I've had the opportunity to call the Alps my backyard, the Grand Teton National Park my backyard, the Cascade Mountains my backyard, and I have become very connected to nature and call nature my home. Therefore, I'm really interested in learning what we are doing to nature and how, basically we're harming nature. So yeah. Green, climate change, global warming, sustainability, one planet. We hear those terms all around the world every day. In the UAE, in India, in Germany, in the United States. These terms are called out by politicians, economists, tree huggers, environmentalists, teachers, students, parents, everyone and everywhere. But what do these words actually mean? What is happening to our world? Why is this happening and how is it happening? What are we humans doing wrong and what can we do to improve the situation? Geopolitical issues, technology, oil, coal mining, population growth, waste of energy, disposal of non-biodegradable plastics. There is a lot we humans are doing which is harming our home, the planet. We are the reasons for the terms global warming, climate change. And this change in climate is affecting our environment. It is affecting the animals we share the planet with. It is affecting us. It is affecting our economy, our health, our daily lives, our choices, our actions, and our decision making. To solve the issues, we have to change the morals and thinking of peoples first. We have to educate society. We have to create awareness and create an understanding of the atmosphere, biosphere, and stratosphere. Today, we will start with ice. In the past, the expansion and concentration around the millennia has fundamentally altered the planet. The cycle of ice ages and periods of warming were caused mainly by shifts in the Earth's orbit around the sun. Today, humans are driving these changes. It basically started with the Industrial Revolution. We have to make clear that these shifts in climate are not naturally caused. We cannot deny the reality of climate change, and most importantly, we cannot avoid our responsibility to protect our natural resources for future generations. The most visual effect of climate change is the melting of glaciers and ice sheets all over the world. As the air temperature rises and the global precipitation patterns shift, the ice is thinning and retreating. This causes a tremendous rise in global water levels. The melting of glaciers and the rise in water levels are the most visual and tangible manifestation of climate change today. What is causing atmospheric warming and precipitation changes? The atmosphere is filling with too much carbon dioxide, methane, and nitrous oxide. This causes our atmosphere blanket to thicken and heat up. We burn an immense amount of coal, oil, wood, and natural gas to transport ourselves, to heat and cool our buildings, to grow and to cook food, to produce light, and to manufacture our items. All of this releases excess carbon, which turns our air into an unnatural substance. Additionally, the flatulence of cattle, sheep, pigs, and goats is responsible for a significant amount of methane released to the atmosphere. Cutting down forests produces the carbon absorption that would normally occur during photosynthesis. It is expected that our atmospheric CO2 will rise from its current average of 385 ppmv, which means parts per million by volume, to 500 ppmv by 2050. Another reason for climate change is the thawing of permafrost lands. Permafrost lands across Siberia and Alaska contain vast stores of carbon. They are now beginning to thaw, which brings a huge increase in global warming. An accelerating melt frees vast amounts of carbon dioxide and methane, which has been trapped in organic matter in the subsoil for thousands of years. James Baylog is an individual who became very intrigued by climate change and created the Extreme Ice Survey. Belag is a photographer, a mountaineer, and a student of natural sciences. He studied geology, geography, and geomorphology. As part of assignments from the New Yorker and National Geographic, he created a project called Extreme Ice Survey, short ICE, EIS. With his team of photographers, scientists, filmmakers, and engineers, he created a portfolio of single-frame photographs celebrating the beauty of ice. His real mission, though, was to deploy and maintain a network of time-lapse cameras documenting the evolution of glaciers throughout time. So he has 27 cameras shooting at 18 glaciers in Greenland, Iceland, Alaska, Canada, the Nepalese, Himalaya, and the Rocky Mountains of the US. And these cameras shoot year-round, every 30 minutes of daylight. His cameras work in temperatures of negative 35 degrees Fahrenheit, winds to over 160 miles per hour, dozens of feet of snow and rain and rockfall. Each camera generates roughly 8,000 frames per year. Belag spent a lot of time and energy documenting the Columbia Glacier in Alaska because Alaska is one of the main contributors to rising sea levels. The Columbia Glacier is a very large glacier. It's about 425 square miles in south-central Alaska. It flows mostly out of the Chugach Mountains to its tidewater terminus in Prince William Sound. The global temperature rise has triggered an increase in the rate of the iceberg's calving, which means that large pieces of ice detach from the glacier and then float into the ocean. William Colgan is the head of the Cooperative Institute for Research in Environmental Sciences at the University of Boulder, and he has been studying the Columbia Glacier for many years. He reports that the Columbia Glacier is currently calving about 2 cubic miles of icebergs into the ocean every year. That amount is equal to 5 times the amount of fresh water that the entire state of Alaska uses annually. It is therefore the single largest glacier contributing to the sea level in North America. It slides about 80 feet a single day and is among the world's fastest moving glaciers. So there was a very visual example of the effects of climate change. And if glaciers in Alaska are melting, what does climate change mean for the big ice sheets in Antarctica and Greenland? If they start breaking, will we be able to stop them? Could they flood the entire planet? What will happen to the land once the ice is gone? What will be underneath the rock? Just a few years ago, researchers and scientists regarded the ice sheets as harmless. It was assumed that it would take thousands of years for them to melt. But with the high global temperatures rise and the carbon that is being emitted to the atmosphere, things have changed. In 1997, the temperatures of the ocean rose by 3 degrees Fahrenheit. That was the same year glaciers began to melt. Now temperatures have increased by over 5 degrees Fahrenheit. The heating of the ocean is melting away the edges of the glaciers. As the warm ocean water is pulled under the ice, heat is delivered from below and the ice melts. The sun is also warming the rock beneath the snow, which creates an endothermic reaction, so the rock bed is heated and then it also melts the ice from beneath. Because of desalination, more water is evaporating into the atmosphere. This results in higher precipitation in the form of rain and snowfall. So more fresh water is flowing into the ocean from the glaciers, and fresh water evaporates faster than seawater, so therefore precipitation continues to increase, and it's a never-ending cycle. Based on research, there will be a 3-foot rise in sea levels during the next 3 years. Florida, Bangladesh, and Vietnam will be devastated, many islands will cease to exist, and coastal cities will have to develop severe coastal defenses. So here's a graph showing the Antarctic ice mass, which is decreasing. Here's an image from Greenland in 1992 and 2002, and you can see the changes on the edges. Here's the graph that shows the increase in global temperature and carbon dioxide, and here's just a little image that demonstrates the atmosphere's circulation. So heat comes from below and heats up the ice underneath the glacier, and then snow and water comes from above from the fresh water that's in the ocean. And then here should be the sun, and the sun, the UV lights are heating up the rock, so the rock beneath the glacier is heated, which also heats the glacier and increases melting. Global warming is also affecting the animals of the polar circle. Seals are struck blind by UV lights, starfish are unable to reproduce in the warm environment, Whales are moving closer to the Antarctic edges because the water is warm enough for them. So they're eating away all the creoles, which results in the death of many penguins because their food is being taken away, and they are unable to find another food source. Another region I found that is very drastically affected by glacier melting is the Himalayan River region. It is home to 1.3 billion people that live in China, Nepal, India, and Bangladesh, and it is almost 20% of the world's population. So around 10 to 20% of the Himalayan River are fed by glaciers. The effects of climate change are drastic because the Yellow River in China and the Ganges will turn into seasonal rivers by the second half of the century. It is expected that they will lose 15 to 30% of water due to glacier depletion. So the glacier melting will reduce the river flow in the low season, yet an increase in temperature will occur because of the heavy precipitation, and therefore there is a risk of flooding. Water availability will decline drastically. In the next 20 years, the 4 countries, Nepal, India, China, and Bangladesh, will face the depletion of almost 275 billion cubic meters of annual renewable water. That is more than the total amount of water available in Nepal at present. While the water is depleting, demand will rise because of population growth and economic development. And in addition to the depletion of the water, it is not possible to use the available water sources because of pollution. The Yellow River Conservancy Committee estimates 35% of the river unfit for drinking, aquaculture, and agriculture. The Ganges in India is polluted to the extent of 50%. All 4 of these countries face the problem of loss of permafrost, deforestation, and the loss of lakes. The loss of lakes results in desertification, which causes an increase in temperatures and creates a vicious cycle. The Himalayan River region will experience a massive reduction in the production of rice, wheat, maize, and fish. This will be the cumulative effect of water scarcity, glacier melting, disruptive precipitation patterns, flooding, desertification, pollution, and soil erosion. This will then increase the international prices of wheat and rice in the world market. All of these aspects will lead to the displacement and migration of 50 million to 70 million people in these 4 countries by 2015. This may cause social and economic conflicts. So now it is necessary for the 4 countries to work together when building resilience, but it's also necessary for the world to be aware of this problem and to assist in any way they can. Yet there's also industries that are benefiting from global warming and the melting of the big ice sheets. Because the Arctic is melting so drastically, it is reviving the Northeast Passage. Global warming is shrinking the Arctic pack, and it's opening new sea lanes and making new navigable routes accessible. Oil companies are mainly benefiting from this because they now have the opportunity to explore more seafloor, searching for natural resources. ExxonMobil in Russia, for example, signed a form to drill in the Russian sector of the Arctic Circle, so they're drilling to see what is underneath the rock. As Prime Minister Vladimir Putin of Russia exclaims, the Arctic is the shortcut between the largest markets of Europe and the Asia-Pacific region. It is an excellent opportunity to optimize costs. So this is the Northeast Passage above Russia, and this is the Suez Canal. In 2009, the first cargo vessel traveled through the Northeast Passage above Russia from Europe to Asia. So this way, the blue line. The vessel traveled from Rotterdam, Netherlands to Yokohama, Japan. This trip was 4,450 miles shorter than it normally would be traveling through the Suez Canal. A Norwegian shipping company, for example, transported a shipment to China via the Northeast Passage, and it took 21 days rather than the normal 37 it would take on the Suez Canal, and the company saved 300,000 euros a trip. In the summer of 2012, a tanker set a speed record by crossing the Arctic in 6 days. The previous record was 8 days. So as the ice is melting, shorter routes and shortcuts become accessible. A LNG tanker from Russia's gas company Gazprom was the first to attempt and succeed in the winter crossing of the Arctic's northern sea route. The tanker traveled down through the Atlantic Ocean, through the Mediterranean Sea, the Indian Ocean, and then up to Asia. The Arctic Monitoring and Assessment Program, which is a Norwegian group studying in the Arctic, forecasts that the Arctic will become ice-free during the summers in the next 30 to 40 years. So now we have all this information. We know what is happening. We know the negative side of it. We know the positive side. We know that we are causing it. So what do we do now? We have to use all this technology that we have for our benefit to find other solutions. We need to employ a range of options that include oil, natural gas, ethanol, coal, and nuclear power used in smarter, cleaner ways, along with proven alternative sources such as wind and solar energy. We will cover the topic of alternative energy in our next lecture. We need to experiment with different approaches such as solar thermal, biomass, and algae. It is time to look beyond oil if we want to conserve our natural resources for future generations. Nothing can replace water, nothing can replace the earth, and nothing can replace the air. So therefore it's our duty to conserve it. As James Balog states in his book, Extreme Ice Now, unless we take action, today's opportunity will become tomorrow's crisis.